You use power rule in calculus. So as you can see here, I have a variable raised to the n power. So meaning whenever you have a variable raised to an integer or a number value, you'll have to use power rule, right? So power rule, when written out, looks like this. So you bring the integer down as a coefficient to the variable and subtract the original number by 1. Let's take a look at some examples of using power rule. All right, let's take a look at how power rule helps us in this simple problem. So we have y equals x squared, right? So let me show you what this would look like using limit definition. So we'd have x plus h squared minus x squared parentheses all over h. So when we expand this binomial, right, we're going to get something as x squared plus 2xh minus, plus, my bad, h squared minus x squared all over h, right? And we see negative and positive, those two are going to cancel out. And then we have an h, which we subtract an h from each, right? So we have this eliminates this h and this eliminates that h. So we have the limit as h approaches 0, we have 2x plus h, and we substitute 0 for h, and we know 2x plus 0 is just 2x. And that's our derivative when we apply limit definition for this equation, or for this problem, right? But if we can simply just use power rule, right? So here, we bring down, right? Let's bring down the problem here, equals x squared. So we first bring down the power according to, right, power rule. Right, we bring it down to the coefficient. So we have 2x, and then subtract the exponent by 1. So 2 minus 1, which simply is just 2x to the power 1, which is just 2x equals the derivative. And that's how power rule can save us so much more time. Now let's look at another example. We have a radical. So the thing with radicals is that we can't directly use power rule. First, we have to remove the root and make it a exponent. So to do this, we know that the cube root of x is simply x to the power of 1 over 3. And now that we have an exponent here, we can apply power rule just as we have. So we bring down the exponent to the coefficient level. So we have 1/3. And then we have x 1/3 minus 1. Minus 1. But because we're subtracting, we have to have the common denominator. So 1 can also be rewritten as 3 over 3. And there we can subtract 1 over 3. Right? When we subtract this, this is just negative 2 over 3. Now, if you look at this, there's something obviously incorrectly written. We can't have a negative exponent. So to remove the negative exponent, we have to bring it to the bottom. We have to bring it to the denominator level. So we have 1 over 3 times x 2 over 3 is equal to y prime, right? But you can also rewrite this into a root form, right? So you have 1 over 3 times root cube root of x squared. That both of these are acceptable answers. Now, let's take a look at this example. So right away we see we see exponential, right? We see the use of an exponent. However, this is not an integer. This is a variable, right? But it's also especially important to note that you have e to the power of x, which means that the derivative of any time you find this, the derivative of e to the power of x will remain the same. So the derivative, or y prime, is just the same as this. So when you see this, you do not need power rule. Just remember that when you see e to the power of x, it will remain the same with derivatives. It will always be the same. This 2x minus 3 in parentheses squared. Now, you may believe that you need to apply power rule here, but you cannot apply power rule. You have to apply chain rule in this example. And the way you would do this is taking the outside function or the inputted function and the derivative of the output function. So in here, you do not need to use power rule. You cannot. You would use chain rule. We see y equals 14, which you can imagine on a graph, right? And let's say this is our 14, y equals 14, right? If we were to graph this right here, this would just be a slope of 0, a slope of 0, right? So we know that the derivative, because the derivative is the slope of the tangent line, meaning the slope of any time you have a coefficient will always be 0. Will always be 0. So the derivative of coefficients is always 0. And power rule does not need to be applied in this example. All right, let's take a look at one more example. We have 1 over x cubed. Now this is going to be similar to how we did with the cube root. We're going to have to convert this to where we have a root, or an exponent on the numerator and not on the denominator. So we're going to have to x negative cube. Right? And now we can apply power rule in this example. So we bring down the negative 3 to a coefficient, x, and then we have negative 3 minus 1. And although we do have a negative exponent, we still subtract 1. Anytime you have a negative exponent, regardless, you will always subtract 1. So this is just negative 3x to negative 4. Right? But you cannot have a negative exponent as your final answer. So you're going to rewrite this as negative 3 over x to the power of 4. And that is y prime. Now, it's important to note that whenever you have your x in this format or a variable in this format, you cannot directly apply power rule. You have to convert it into an exponent, right? Or convert this into an exponent and convert this into a numerator exponent. You cannot take the derivative of a variable that is in the denominator, right? So when you have this, you always have to convert it back into a exponent or into a numerator exponent, and then you can apply power rule. If you have any more questions, make sure to comment down below. As always, if you enjoyed, please consider liking and subscribing. Thank you, as always.